Okay, an object of mass 4 kg is attached to a string with a force constant of 100 Newton per meter. It is oscillating on a horizontal frictionless surface with an amplitude of 2 meter. A 6 kg object is dropped vertically on top of the 4 kg object as it passes through its equilibrium point. The two objects stick together. Okay, determine A. The change in amplitude of the oscillating system as a result of the collision. Okay, the change in the period of the motion and the new total energy of the oscillating system. Okay, so question A asking for change in amplitude, right over here, change in amplitude. Question B asks for change in period, and then question C asks for the new total energy of the system. So the new total energy, AT2, yeah. Okay, so look at here. You have to check the keywords. Here he says about collision, collision, and then he say about stick together. So this one will involve the, about the conservation of linear momentum. We will use about the conservation of momentum concept in this question, yeah. Conservation of linear momentum. We will use equation about conservation of momentum, yeah, for this. Stick together. They have the common velocity v. They have the common velocity v. Let's put a v there. Okay. Same final velocity lah. I can say. Okay. So it gives us the object mass of object. Okay, 4 kg, force constant. Force constant is K value. This is the mass. We have two masses, isn't it? We have, this is considered as mass 1. And then we have 6 kg object drop vertically on it. So this is considered as mass 2. Suddenly add on the 4 kg object. So conservation of momentum has the two masses, right? Mass 1, mass 2. Okay. It is oscillating on a horizontal. This system is a horizontal frictionless surface. Frictionless means the total energy is the total energy in the oscillation is always constant, not losing any energy. Unless you add another mass, then the total energy will change. Yeah. Okay, we will look on that later on. So it has the amplitude. This is this amplitude. Okay, amplitude. So this object will drop vertically on this object as it passes through the equilibrium point. When is it happen? It happens during the equilibrium point when the 6 kg drop onto it. Okay. So how going to do question A? So before we even try out this question, we should actually draw. What's happening in the system. Then we are more clear about the situation. Yeah, we should draw. So let me draw it out. Okay, now, so I've drawn already. So this is this one is initial condition. Yeah, before the object, the second object 6 kg fall onto the mass 1 4 kg. Okay, so it undergo oscillation. The spring constant is 100. Okay, so it oscillates with amplitude 2 meter, isn't it? Initially is amplitude 2 meter. Okay, so it has velocity 1 at the equilibrium position. Okay, so when it goes to the to the maximum amplitude, all the energy change to potential energy. All the energy change to potential energy. Okay, at equilibrium position, it has only kinetic energy, and then all the kinetic energy change to potential energy. Okay, and then the 6 kg fall onto the mass 1. Okay, fall onto it. So the velocity suddenly at the equilibrium position the velocity no longer v1, it drop into velocity common velocity because they stick together, isn't it? So here got collision happening at the equilibrium position. So the velocity of the whole system, 4 kilogram plus 6 kilogram, no longer travel at this velocity v1, but it goes to common velocity. This common velocity we need to find out using the conservation of linear momentum. Okay, when two objects stick together. Yeah, still remember the formula? So we're going to find out this common velocity later on. And because of the velocity changes, so the kinetic energy here also changes. Become K2 lah. Last time is K1, U1. Okay, last time is K1, U1. Now, because velocity changes, so this one become kinetic energy, so become K2, different velocity already. Okay, so and then the potential energy later on also become different. The amplitude also become different. Okay, so now we're going to do step by step. I just picture out what's happening here. Okay, so we're going to what we're going to do is, first of all, we find out what is the total energy initially. Yeah. Okay. Okay, so let's find out what's the total energy initially at this one. So the formula for total energy is half m omega square a square, and m omega square is actually is the k value. Okay, it's the k value. So let's write it down. So before the object drop onto it, what's the total energy? Let's find out. So the total energy initially, is half m omega square a square, and we know that k is the m omega square, isn't it? The k itself is the m omega square. Okay, the spring constant, so we can substitute 100 there, and then the amplitude is 2 meter. Yeah, the amplitude is 2 meter. So 2 square. So what do we get? We will get, this one is 4 times 100, 400. So this is 200 joule. Okay, 200 joule. Okay, so that's the initial energy. So how about the after the object drop onto it? What is the final energy? Okay, so we need to find out. Okay, we need to find out the common velocity here. Okay, we need to find out the common velocity here. Okay, after it drops. So how to find this common velocity? We use the concept of collision, conservation of linear momentum. So very simple. Just just use m1 u1 plus m2 u2 equal to m1 plus m2 v. Okay. So m1 is the 4 kilogram. Initially, it has 4 kilogram. The initial velocity is okay. This initial velocity. What is the initial velocity? We need to find out this one. We don't have the initial velocity, in this position. Okay, we have to go back to the original condition. We need to know what is this v1. What is this initial velocity? Not this one. This is potential energy. Just rub that off first. Okay. What I can say is we already have the total energy at initial condition, right? This one is actually we can say this one is the maximum potential energy at the amplitude, because this is the total energy. This is the total energy, right? So at the amplitude, it has 0 kinetic energy. The kinetic energy here is 0. All the energy has changed to potential energy. So all this total energy become the maximum potential energy at the amplitude. At amplitude, isn't it? So we can say over there, here the total potential energy, this is the at this amplitude, no kinetic energy. All the total energy here become the potential energy, which is 200 joule. Okay, understand? But at equilibrium position, okay, but at equilibrium position, the potential energy here is 0. But the kinetic energy here is 200 joule. Understand? So at equilibrium position, it has maximum kinetic energy. When it goes to the amplitude, all the kinetic energy change to potential energy. But when you return back to equilibrium position, all these 200 joule from potential energy change back to kinetic energy. Okay? So from here we can find the velocity, initial velocity at equilibrium, for the 4 kilogram. Okay, let's find out. Let's find out. So what the kinetic energy? Okay, the kinetic energy. Okay, we can write as we can say here it has the, this is also the maximum. You can write that as this is the maximum velocity at the at the equilibrium, right? Okay, so we can find out. So we can say that the K maximum is also the K maximum is also the the K maximum is also the total energy. It's also the total energy, which is the 200 joule, right? So we can find out the velocity, half mv square. Okay, that is the maximum velocity. Okay, this is only for mass 1. Okay, all right, let's find out. So the mass 1 is what is the mass 1? 4 kilogram, right? 4 kilogram. 4 kilogram. So V max 200. Okay, so cut it off. Is 2. And then what is the maximum velocity here? Maximum velocity here is 200 divided by 2, you get 100. 100. So okay, V max here is 10 meter per second. Okay, after we square root, okay, 200 divided by 2 is 100. 100 square root 100, you get 10. So this is the 10 meter per second. So we can write there the velocity maximum here. The velocity maximum here is 10. Understand? Velocity maximum here is 10. The amplitude here is 2 meter. The maximum velocity here is 10. Okay, it's 10. So this 10 is the initial velocity here before collision. Okay, before collision, we can put 10 over here. This is 10. Okay, before collision. Now mass 2 drop onto it. Okay, it become a new velocity. Become a new common velocity. New common velocity. Before the 6 kilogram drop onto it at the equilibrium position, before it drops, the 4 kilogram is travel at 10 meter per second. Understand or not? 10 meter per second. Now suddenly 6 kilogram fall onto it. Both of them stick together. Yeah, both of them stick together. So the velocity change from 10 into common velocity. Surely drop lah. Yeah, it will drop from 10 to a lower value. So we need to find this common velocity here. Okay. So initial velocity for 4 kilogram is 10. So I put 10 already. How about the second mass, the 6 kilogram? Does it have any initial velocity? No, he said he dropped the 6 kilogram is dropped vertically. Do you see that? It dropped vertically. So we can say drop vertically. So we can say the U2 is 0. Here we can say U2 is 0. So that means the 6 kilogram, because vertically, drop vertically, so it doesn't have velocity horizontally. It doesn't have any horizontal velocity. So the 6 kilogram does not have any horizontal velocity. So we can say this one is 0. This is 0 because U2 is 0. Understand? U2 is 0. It dropped vertically on it. So it doesn't have any horizontal velocity. It only has vertical velocity, but that doesn't matter. Yeah, the motion is just horizontal. So drop vertically, that means U2 0. That means no horizontal velocity. So this is 0. Okay. So now you combine two masses, stick together. That 4 plus 6, we get the V common. Find out the V common, which is this is 4 times 10 is 40, and then equal to 10 V common. Okay, so it is 4 meter per second. So that is the common velocity. Understand? 4 meter per second. So now when both stick together, they travel at 4 instead of 10. Instead of 10 last time, now it dropped to 4 because heavier already, become heavier. Okay, the common velocity becomes 4. So now we need to find out what we need to find out. We need to find the amplitude, the new amplitude. Last time amplitude is 2 meter. So now what's the new amplitude? Okay, what we can say here, we also can find the okay, let's find out the kinetic energy. Okay, let's find out the kinetic energy. The kinetic energy. So this one is the, we can say this common velocity is the maximum velocity because this is at equilibrium. How to write it? Equilibrium. This one is at equilibrium. Displacement 0. Understand not? This common velocity is actually the maximum velocity for the second condition after the object dropped onto it. It is the maximum velocity at the equilibrium position. So this one we can find the, we can find the total energy. We can find the total energy. We first find the maximum kinetic energy. Because we already got the maximum velocity, we can find the maximum kinetic energy. Understand? We can find the Kmax. Kmax is equal to half mv max square. Let's find out. So the the mass here is the total mass. Yeah, m1. This is the total mass. Understand? Total mass, which is mass 1 plus mass 2, which is 4 plus 6 is 10 kilogram. Understand? So this one is 10. Okay, and then what's the Vmax here? Vmax here is 4. 4. So let's calculate. Okay, our Vmax here is 4. Okay, so let's calculate 4 square. Okay, times 10 divided by 2. So I get 80. So the maximum kinetic energy here is 80 joule. Okay, 80 joule. Good. So this one is the new total energy. The new total energy 82 lah. The new total energy. Last time 80. Because when maximum kinetic energy, that is the total energy. That's the total energy. So this is the total energy. Understand? At maximum kinetic energy at equilibrium, this one happened at equilibrium. At equilibrium, understand? At equilibrium, the kinetic energy is maximum. Kinetic energy is maximum. The potential energy at equilibrium is 0. Okay. So all this maximum kinetic energy is actually the new total energy, 80 joule. So compared to last time, the total energy is 200 joule. The total energy has dropped from 200 to 80. You see that? Dropped to 80 joule already. So now, actually we also got already the answer for C. The new total energy of the oscillating system is 80 joule. We got already. But never mind. Okay, now we're going to find what is the amplitude, the new amplitude. Well, how are we going to find the new amplitude? How are we going to find the new amplitude? We know at amplitude, the kinetic energy here is 0, right? Because all the kinetic energy changed to potential energy. So we need to find out. So now we do for at amplitude. Okay, amplitude. We can say want to find the maximum potential energy, right? We want to find maximum potential energy. At amplitude, the kinetic energy is 0, right? Because all the kinetic energy changed to potential energy. So the maximum potential energy, so at amplitude, the potential energy is maximum. It is equal to the, we can say equal to the total energy, right? Equal to the total energy, because no more kinetic energy. All the energy is in the form of potential energy. It is equal to the new total energy, which is 80 joule. 80 joule. Okay, 80 joule. So for 80 joule, we can find the amplitude lah for the maximum potential energy. Okay, so we can say, what's the formula for potential energy? Potential energy is half kx square, right? Half kx square. Potential energy, but maximum, when maximum potential energy is half, we know potential energy, where the potential energy is half kx square. So when maximum potential energy, it is using amplitude, half k amplitude square, right? It is amplitude. The displacement is amplitude. At the maximum potential energy, the displacement is amplitude. So potential energy is maximum. Okay, so we can write that down. Half Ka square, equal to 80 joule. Okay, so we can find the amplitude. Yeah, the amplitude, the new amplitude. So the K is, what is the K? Spring constant, 100 joule. It's still 100. You see, the spring constant is still 100 Newton per meter. The spring never change. 100. Just put 100. So that's 100. And then the new amplitude is, let's calculate. What's the new amplitude? Let's calculate. Okay, the new amplitude is 1.2649 meter. That's the new amplitude A2. Okay, that's the new amplitude. Okay, so we can say the new amplitude can write over here. 1.26. 1.2649. 1.2649 meter. Last time is 2 meter. You see that? Last time is only 2 meter. Last time is 2 meter. Now it dropped. The amplitude dropped already because it become heavier, right? The amplitude dropped to 1.2649. So from here we can find the change in amplitude, right? We can find the change in amplitude. So the answer is, what's the change in amplitude? What's the change in amplitude? So we can write it down there. So the change in amplitude is equal to, just take final minus initial. Final minus initial, A2 minus A1, which is 1.2649 minus 2. So it is equal to minus 2. So it is equal to negative 0.735 meter. The negative sign here means it dropped. Yeah, the negative. So the negative sign here means it. The negative sign here means amplitude decrease. Understand? Amplitude decrease. That means the amplitude has decreased. So is the answer correct? The change is negative 0.735. Yes, that's correct. The change in amplitude is 0.74. It didn't put negative, but not so important. Negative, it means it dropped lah. Here negative means the amplitude drop or amplitude decreases. Okay. So it decreased to 1.2649 because the energy also decreased. You see, energy also decreased from 200 to 80 joule. So that's the answer. Okay. Okay, understand? So okay, let's do the next questions. See the amplitude change from 2 to 1.26. The new total energy also we can find. The new potential energy also is we can say it is the can write it down. It is 80 joule. 80 joule. Here 80 joule for kinetic energy. See? So from 200 drop to 80. Drop to 80. Amplitude drop from 2 to 1.26. Okay, so we almost done the questions. So question B, what is the change in period of the motion? Okay, very easy this one. This one change in period, so you just use what? You just use the formula. You know, question B, you just use a formula to compare. What formula? We're going to use this formula. Period equal to 2, because it's a spring mass system, period equal to 2 pi square root m over k. We're going to use this. Yeah. So we have first period and second period, right? So we need to calculate both of them. And then after that, we can find the delta period. The spring, so the difference is just, this is M1, this is M total, mass 1 plus mass 2, yeah? Okay, so let's calculate 2 pi. The mass 1 is just 4 kilogram, okay? 4 kilogram, and the spring constant is still 100, right? So what's the answer for this one? What's the answer for this one? 4 divided by 100, square root answer, and then multiply 2 pi. So the initial period is 1.2566 seconds, and for the mass total, if the second period, when they combine together, this one is actually mass 1 plus mass 2, yeah, combined. The spring is still the same, K 100. So this one is, the top now is 4 plus 6, right? 4 plus 6, okay, 4 plus 6 over 100. So what is the answer? 4 plus 6 is 10. 10 divided by 100, okay, and then square root times 2 pi. Okay, so I got the new period is 1.9869 second. Okay, so I can find the change of period is the final period minus the initial period, which is 1.9869 minus the 1.2566. So I get, so what do I get? The answer is 0.73 seconds. Is that correct? Is that correct? So the period becomes longer, you see? The period becomes longer because heavier. Now become heavier. You have two objects stick together. It become heavier. The period takes a longer time. The period takes a longer time. Increase from 1.25 to 1.98. So the increase is, you see, the change is the positive. Positive means increase. Positive means increase. The period increase 0.73 seconds. So is that correct? Yeah, the change of period is 0.73 seconds. That's correct. That's correct. Okay, the period increase. So finally, what is the question C? What is the new total energy of the oscillating system? Oh, new total energy. So want to find the new total energy. We already got it in the first question, right? The new total energy is actually the 80 joule. Yeah, 80 joule. Yeah. So question C, the new total energy is equal to both the maximum kinetic energy that you calculated or the maximum potential energy you calculated, which is 80 joule. Okay. So 80 joule. So that's the answer. Okay. So the answer is 80 joule. Okay. So that's all for these questions. I hope you also this is correct. So I hope you understand the whole questions. I hope you enjoy. So that's all. I just have you can have a quick look through to the solutions. Okay, this is the questions and this is the diagrams to describe the whole situations. The amplitude changes from 2 to 1.26. Potential energy also changed from 200 to 80. Same goes to the kinetic energy, drop from 200 to 80. Okay, initial maximum velocity is 10, now become common velocity is only 4. Okay, the mass last time is only 4 kilogram, it has become 10 kilogram this time, 10 kilogram, but the K is always constant, spring is always constant, 100. Okay, we use conservation of linear momentum to find the common velocity, and the rest is all the formulas. Yeah, remember the maximum kinetic energy is always the total energy. Same goes to the maximum potential energy, also is the total energy. This one, remember about this one. The Umax or Kmax, is always the total energy of m omega square a square. Okay. At equilibrium, the kinetic energy is maximum, but potential energy 0. At amplitude, the kinetic energy becomes 0, but potential energy becomes maximum. That's the key for everything here. Okay, and then just use this formula, period equal to 2 pi square root m over k for the spring mass system. Alright, so that's all for, see that the mass here, you can see the relationship when the mass increase. Yeah, last time it's only 1 mass, now become 2 mass. So when the mass increase, the things become heavier to oscillate, so it takes longer time, longer period to oscillate, so it oscillates slower. You can say it oscillates slower now. Yeah, oscillates slower now because of higher mass. It oscillates slower now compared to last time, only 1 mass. Okay, so that's all for this question. See you. Bye bye.